atomic mass unit, U or AMU. In 1961, physicists and chemists agreed to use carbon-12 element instead of hydrogen or oxygen or iron as reference element for calculating atomic mass unit. This is because 1 mole of carbon-12 equals to 12 grams exactly. The other elements have isotopes that made it difficult. 1U or AMU equals to 1/12 of the mass of carbon-12 atom. 1 mole of carbon-12 element equals 12 grams. 1 mole equals Avogadro's number, and that equals 6.0221409 times 10 to the power 23 atoms of carbon-12. So I need to find the mass of carbon-12 one atom. Na equals Avogadro's number, so Na equals 12 grams. That implies that one atom equals 12 divided by Na. So that many atoms is 12 grams, and one atom will be 12 grams divided by Na. One atom equals 12 over Na grams, and what I've done is I've divided by 1,000 and I've times it by 1,000, so there's no difference. If I cancel that 1,000 and that, I get back to that. In doing that, I know 1,000 is a kilo, so I'm replacing the 1,000 by K, so I put a K there, so that becomes kilogram. So one atom is equal to 12 over 1,000 Na kilogram. But 1U equals 1/12 of mass of one atom of carbon-12, and that is the mass of one carbon of carbon-12, so I need to put that into here. Now 1U equals 1 over 12 times 12 over 1,000 Na kilogram, and that meant the 12 will cancel 12. 1U equals 1 over 1,000 Na kilogram. So 1U equals 1 over 1,000 Na kilogram. So this is the famous value, and that equals 1 over 6.0221409 times 10 to the power 23 times the 1,000 kilogram, and that is 1 over 6.0221409 times 10 to the power 26. Same base, when you're multiplying them, you add the exponent. 1U equals 1 AMU, which equals 1.660539,029 times 10 to the power minus 27 kilogram. So this is the famous value for 1U or 1 AMU. 1U equals 1.660539,029 times 10 to the power minus 27 kilogram. Now to look at Einstein mass energy equivalent. That means we're converting the amount of mass into energy. So we're going to use Einstein energy equation, E equals mc squared. And also we're going to use 1 electron volt, which equals to 1.602177733 times 10 to the power minus 19 joules. So I need to divide both sides by this value. In doing so, I get joule equals 1 over 1.602177733 times 10 to the power minus 19 electron volts. So this is what I'm going to be using to convert the mass into energy. So first I'm going to replace joule with this value. So I'm going to replace that with this value. So now I've replaced joules with this value, and that becomes this. So now I'm going to rewrite this equation by dividing it by 1,000,000 and timesing it by 1,000,000. 1,000,000 cancel 1,000,000. So I'm going to replace the 10 to the power 6, which is 1,000,000, by m. And m stands for mega, and mega is 10 to the power 6. So I'm just going to replace that with m. So therefore, I'm going to get MeV. And so the new value will be this value, MeV. So this is the new equation for energy in mega electron volt. So now I've put in the values in. Minus 19 plus 6 is minus 13. Same base. If you're multiplying same base, you add the power. So that's minus 13. I want to do the same with these ones here. that's 10 to minus, and that's 10 to power 2 times 8 will be 16. So that'll be the square of that times 10 to power 16. And 16 minus 27 is what I'll be doing next. So now we've got this new value for E, which is that value, and the square of that one, we square that one because that's squared, times, well, that's 10 to power minus 27 plus 2 times 8 is 16. And then we got the final value in the bottom here. So we need to simplify this further. So now the value of E, I'm only working on the power of 10 here. So that's 10 to power minus 11, and I've got 10 to power minus 13. And that will go up, it will become minus 13, because if you're dividing the exponentials, exponent, like 10 to power minus 11 divided by 10 to power minus 13 will become 10 to power minus 11 minus 13. So minus is plus, and that'll be 13. 11 minus 11 plus 13 is 10 to power 2. So that simplifies it. And now if I plug the values in, I get the value of E equals 931.494 mega electron volts, which can also be written as 931.5 mega electron volts. E equals mc squared, where m equals E over c squared. If I replace m with 1U, that equals energy of 1U over c squared, and 1U equals 931.5 mega electron volt over c squared. It is common to see 1U mass to be written as 931.5 mega electron volts per c squared. That's the mass of 1U, or you might say that's the mass of 1 AMU. But the energy of 1U will be also written as 931.5 mega electron volts, because if you multiply the mass by c squared, you will cancel that c squared to get the energy value. Application. So we've got these particles, protons, neutrons, electrons. These are the absolute mass of proton, neutron, and electron. This is the U values because we divide the proton mass by the value of U, and we get that. And if we divide neutron by that, we get this one. If we divide electron by that, we get that. And obviously, to get the energy values, we multiply each U is 931.494. So we just multiply that by these values. So that value times these values, we give you this. And that's how we find the energy values. Question. Helium nucleus 4,2, that's atomic mass, atomic number. Helium 2 plus, it has lost 2 electrons. That's why it's called helium nucleus. It's only looking at the nucleus. And the atomic mass unit is 4.00153. Find the binding energy. So here's helium, and inside the nucleus, you have 2 protons, 2 neutrons. So the atomic mass unit for the helium is that value, and for proton is this times 2. For neutrons, it's that one here times 2. You add them together, we get this value. So the difference between these two masses is 0.03035 U. So the binding energy is the difference in mass times the energy for 1 U, and that is 28.27 mega electron volt. That meant that the energy released when these protons and neutrons were taken apart is 28.27 mega electron volts.